we see building on those systems, but they're going to have to take into consideration a new reality and probably have a time frame, like Hal's been talking about, that is more than the 5 and 10 years that we've worked with in the past. If we can do that and communicate it back to the public, you know, we'll be making some progress. But no question, right now there's a disengagement by the public. They're learning more off of YouTube and other sources of the information technology than they are from the traditional basis of information.
Just a follow-up.
A follow-up question, and then over here.
Do you think that would be like a state funding issue, or do you think it should be local funding? Or how?
It's going to be a combination. I mean, it's going to be, in the near term, it's going to be federal funding that is spent at the state and local level. There isn't any money at the state and local level to do any of this. Zero. Minus zero.
You want to say just a comment, just from the standpoint of the Park Service. I mean, one thing we know is take a landscape like Everglades. It kind of goes back to my point. It's not just about natural resources, but also cultural resources. We need to do scenario planning. We need to do vulnerability assessments, because it's not just 100 years out. We need to be making decisions, for example, investment decisions or preservation decisions, maybe in the next handful of years. And I think one other thing to point out is the science is not fixed. I mean, we did this publication right here about 2 years ago, and there's information in here that I guess I would call stale. We're going to have to, the science is going to be a moving target. I think that's an important factor to think about here.
Sir.
Ronnie Best with the U.S. Geological Survey. To build on what Superintendent Kimball said earlier, Everglades Restoration Plan really captures the water that presently is lost to tide, much of which is upstream. And obviously that's going to provide an additional cistern, if I can use that term, internally for freshwater supply. The advantage is that provides both nature on the natural system side of the levee and humans time to adjust. And if we are back to Hal's, Dr. Wallen's suggestion of 3+ feet in elevation, we're going to change what we do. We don't know yet. And that's what the advantage of SURP restoration. It's only a few pennies. It's just $20 billion. So that gives us time for us and nature to adjust.
Okay, yes, sir.
I had a couple of comments, and it's distributed throughout the panel, science and policy. First one is for the energy systems and cap and trade that you were talking about. Are there any provisions for carbon dioxide sequestration here in Florida, and particularly South Florida? Second comment or question is, in the Everglades National Park, you talked about this whole funding issue now changing. What impact is it's going to have on the ASR projects? And two, instead of distributing it all around the lake, are you planning, or is it in the works, that you distribute it spatially throughout the park away from Lake O, because the rainfall itself would be spatially very variable. The intensities would change with the climate change happening. A third one is on this little projection that Fred showed on the screen with sea level rising and water level responding as it is. And we know gradients in Florida are flat, 1 in 1,000, more than that, or sorry, even less than that. So a 1 foot rise would correspond to a 1 foot rise, probably 1,000 feet inland. And not even that, because seawater density is higher, so that response is not going to be linear. Second is when you start going inland, you come across all these canal structures. So now your water table is not going to respond linearly at all. It's going to depend all on what the canals do. Plus, you have a precipitation decrease inland or increase inland. So this whole gradient staying the same and water level increase depends on the flow being maintained from the inland side, which might not be the case at all, because the precipitations would go down by 10, 20, 30%, or I don't know, increase maybe, because the models are uncertain. So with that, I would stop.
That's why we need that scenario.
is good, ladies and gentlemen, I'm sorry, this is going to be our last question. Questions, and I think the panel panelists will be available to take some one-on-ones.
You wrote all these down, right?
Oh, no, I wrote my answer down.
Okay, let me answer what I can of it. Number one, the ASR projects. To date, they don't work. So the answer is the 300 ASR wells that are going to go around Lake Okeechobee is going to be 0. Because they produce arsenic, they don't know how to get rid of the arsenic. DEP won't even let them put it back into the class 5 well they came out of. So I probably would set that aside. That's not really a solution, and which is why I think the district and everybody else is looking for other solutions for storage. It may prove out at some point that there are places where ASR works, but like I said, there's only one well in southeast Florida that works, and it's in Boynton Beach, and it only works in 1 million gallons a day. And if you look nationally, that's about the rate at which ASR wells work. And I can go into, I can give you a book I wrote on it. Okay, so the second thing is on the how far does the water move in? The 1 to 1,000 grade, I think that your thought process on that, we want to, in a very short period of time, may be correct, but here's the issue. Ultimately, you're looking at a very slow, steady, basically almost a steady state increase because of the amount of time that it takes to do that. So the reality is that the water is going to creep with time to where it matches whatever the contour is. So if that contour, that 1 foot contour increase it's going to do is a mile inland, it will, over a period of time, find its mile inland. And then ultimately, the groundwater that sits with that, there's a natural equilibrium that groundwater will reach with the seawater. Okay, at that point is not static. It's going to migrate until it reaches that equilibrium. So what you'll find is that groundwater will actually increase in head, and that's what it does right now. I mean, it basically sits at 2 foot NGVD. That's what you can drain to naturally. And it doesn't really get much lower than that unless you pump it somehow. So if you start saying my sea level rise is going to give me 3 foot, which means the high tide is at 5 foot, sea level ultimately is going to, or groundwater level is ultimately going to reach equilibrium at that point. That's the soil storage issue. It's not going to happen tomorrow if it does it, but if it sits there at the same point for the next 20 years, it will absolutely go that. And you can do the models that will show that you can go very long periods of time like that with the traditional rainfall. Now, let me make one other comment about the rainfall. If anybody's really interested in trying to look at some details of this, there's a study that was done at UF by some folks it's Marshall et al. 2003. And what they basically came up with was the rainfall pattern looks like a 12% decrease over the southern half of the state of Florida. And the reason for that is that it's basically convective rainfall is where all of the change is, which means summer rainstorms. And the reasons they believe that has happened in part is because they see a similar change in the extremes of temperatures during the same period. So colder is cold, warmer is warm. And if you follow agriculture for any significant amount of time in Florida, what you find is that agriculture has moved the orange groves south, not north. You would think if we're getting global warming, then we should be moving the orange trees north. The reason they moved south is that places like Frostproof, named because it was frost-proof, now freezes periodically. And the reasons that Marshall and et al. Went ahead and suggested that those two things are not unrelated is because if you see the decrease in water stored in wetlands, what that does is it will allow the air to get colder in the wintertime, and it reduces the amount of water that's available for evapotranspiration in the summertime. Hence, convective rainfall will be less. So what they basically said was because there's no active surface storage in wetlands throughout the state, and they have a diagram in there that shows you what they think historically it was and what it is now. But they basically said the destruction of the wetlands has created, in part, the extremes that we see. Now, add sea level rise to that problem, and you see groundwater levels migrate up, and you may see some further changes climatically. That's, you get into a lot of uncertainty, but the reality is you're going to see different flow.
Let me use Fred's segue from Fred's last comment. Is what we've been talking about this afternoon from a science and policy standpoint. And we're a long way from having our arms around it, is what happens when we add that sea level rise. You know, and that is what we'll be studying at universities, at the Water Management District, and we'll have meetings like this in the future so we can update ourselves. On behalf of the chair, Ephraim, and Yapos, the director of the school, and myself, and all the participants, we appreciate your spending the Friday afternoon with us, and please have a safe ride home.